Okay, I'm back. And so in, let's say, the early, late 19th century, early 20th century, we had ideas that the Earth was very, very old. And we could use relative dating to show that this rock is going to be older than this rock up here. But we couldn't assign actual dates to it until we came up with the idea of radioactivity. So radioactivity comes from the nucleus of an atom. So we've talked about atoms when we talked about minerals and rocks, but we didn't really ever talk about the nucleus. So a nucleus of an atom consists of the protons and the neutrons. And so there are different kinds of nucleuses called isotopes. So for example, every hydrogen in the known universe is going to have one proton in it. However, you could have different isotopes of hydrogen. You could have hydrogen that would have one proton and 0 neutrons in its nucleus. You could also have hydrogen that is going to consist of one proton and it's going to have one neutron in it. And then you could have, there's even a third kind of hydrogen that's going to have one proton, because every hydrogen has to have one proton. That's the atomic number. And it would have 2 neutrons in it. So those 3 forms of hydrogen are going to be called isotopes. Now chemically, they're going to be identical to each other. So in chemical reactions, all 3 of those hydrogen forms would behave the same chemically, but they're going to be, the more neutrons it's got in it, the heavier the isotope is going to be. So if you've ever heard of heavy water, so water is H2O, and so if the hydrogen that's in that water, it has a lot of neutrons in it, then that's going to make the water heavier. And so that's where we get the word heavy water from. So how do we name different kinds of isotopes? So there's a special way of doing it. And first we write down the symbol of the element. So in this case, it's going to be carbon. Okay, and then we write underneath it the atomic number, which is never going to change. So for carbon, it's always the 6. So when you look at your periodic table, it's the number that doesn't have the decimal point. And then up above it, you're going to write down the mass number, which is going to be the number of protons, which is going to be 6, plus the number of neutrons in that particular isotope. So for example, carbon 12 means it's going to have 6 protons and it's going to have 6 neutrons. So 6 plus 6 makes 12. So those are 2 different isotopes of carbon. Okay, the next thing that we want to mention is that some nuclei are unstable. So in general, in the nucleus of an atom, it likes to have roughly equal numbers of protons and neutrons. Now, for your heavier nucleuses, you need to have a few more neutrons in there. But just for the sake of argument, let's say that a nucleus likes to have roughly equal numbers of protons and neutrons in its nucleus. So if it has too many protons, then what will happen is the electromagnetic force, so remember protons are positive, positive charges repel, and so if you had too many protons in your nucleus, it would be unstable. It would want to blow itself apart because of that electromagnetic force. And very similarly, if a nucleus has too many neutrons, then it also is going to be unstable. So how can a nucleus get rid of excess energy? Well, one method is just to give off a gamma ray. So a gamma is given by this, and a gamma ray is a type of electromagnetic radiation. So on the electromagnetic spectrum, you've got radio, and then next to it is infrared, and then next to it is visible light, and then next to it is ultraviolet, and then X-rays, and then gamma rays. So gamma rays give off the most amount of energy. So you could have a nucleus that has the right number of protons and neutrons, but it just has too much energy. And so it's going to give off a gamma ray, and then what's left over is just the original nucleus. So notice that the nucleus did not change, it just gave off some energy. Okay, another way that a nucleus can give off energy is by giving off an alpha particle. So this time, the alpha particle, we want to turn this one on its side, and an alpha particle is going to be a helium nucleus. So that means that it's going to have 2 protons and it's going to have 2 neutrons. So 2 plus 2 is 4. So you could have a nucleus that's just too big. And the bigger a nucleus gets, the more likely it is that it's going to tend to fall apart in a nuclear reaction. So if that nucleus gives off 2 protons and 2 neutrons, so it's going to give off the alpha particle, then it's going to be the original nucleus minus 2 protons and 2 neutrons. And so sometimes that can help stabilize the nucleus. So that's going to be called the alpha particle. Okay, now the last one is the really strange one. And this is going to be the beta particle. And there's 2 different ways of doing this. So let's say that your particular isotope has too many neutrons. So what we need to do is to change one of those neutrons into a proton. So if it's got too many neutrons, then we're going to get rid of the neutron and change it into a proton. Okay, but now let's look at the charge. So the charge of the neutron is going to be 0. It's neutral. And then the charge on the proton is going to be positive. So in physics, you can't do that. So you can't just invent a particle. The particle cannot just change its charge like that. So what we need to do is it needs to give off another particle, which we're going to call the beta particle. And another particle is given off, which we don't care about, so don't worry about this. But the other particle that would be given off is going to be called a neutrino. And that's this, it kind of looks like a V thing, but that's called a neutrino. That's another particle that's given off. Let's not worry about it. Okay, but let's concentrate on the beta particle here. So what would you need to add to a positive in order to turn it into a 0? You would need to have a negative. So at the time when they investigated these nuclear reactions, they didn't know what these particles were, so they just called it a beta particle. Well, it turns out that this thing, it has a negative charge, and it's incredibly small, and that's the definition of the electron. So it turns out that the beta minus particle is just the ordinary electron. So when this is going to be called beta decay. So you had alpha decay, gamma decay, and then down here, this is going to be called beta decay. So in beta decay, What happens to the nucleus is one of its neutrons goes away, and instead of the neutron, now you have a proton. And that might help stabilize that particular nucleus. Now, you could also have a situation where you've got too many protons. So here, let's say you've got a proton, which is positive, and it changes into a neutron, which is 0. What kind of particle would have to be given off? Well, it turns out that it's going to be a beta particle, just like this one up here, but it's going to be a beta plus, and then it also gives off the neutrino. So these two particles are the same, except they have opposite charges. And so this beta plus is a positron. This was the electron. This one is its antimatter particle. And so this is the opposite of the electron, which is going to be called a positron because it's got that positive charge. Okay, the point is that if you have a nucleus that is unstable, either because it's got too much energy, or it's got too many protons, or it's got too many neutrons, there is a way of getting rid of it either by undergoing alpha decay, gamma decay, or beta decay. Okay, so let's take a break, and when we come back, we're going to talk about the different steps that a nucleus goes through until it finally ends up being stable.